Hello class, happy week 5. You know what that means mathematically. We are 1/3 of the way done with the course. Imagine that, just 2/3 left. So this week, in terms of what we need to learn and cover, we have some specific topics and concepts being introduced. You'll be seeing and reading about the 3 sigma or 6895-99.7 rule. All that is, in a nutshell, it represents the percentage of standard deviation of cases within standard deviations there are in the normal distribution. So, for example, 68% of your data, if it falls within one standard deviation above or below, refers to the 68, 2 standard deviations above or below at 95%, and 3 standard deviations above or below at 99.7. This is also where that term 6 sigma or lean 6 sigma, if you are going down that track or ever heard of it, it is actually referring to the 68, 95, 99.7 rule. Except instead of going 3 sigmas out, it goes 6, okay? So with that, we're also going to be delving into sampling, the types of samples, so simple, random, clusters, stratified. Basically, a cluster sample is just a subset of the population. A stratified sample is basically categories of similarities. And knowing the difference that you're always drawing your sample from your population. Your population is just the group of units you draw your sample from. So when you think of sampling, it's imperfect, okay? It's not a perfect process. There's always going to be this thing called sampling error, okay? It never goes away. You can never draw a perfectly random sample from a population. So you want to make sure there's things in your sample. And a sample can be a group of people. It could be a sample of tires on the production line, the bottles in a beer factory, a brewery. So just don't get caught up that it's about people per se. So you want your sample to always be representative. And to do that, okay, representative meaning your sample is as close in appearance, if you will, and characteristics as your population. There's things that you can do, primarily randomization, okay? So what does that mean is that instead of trying to be very deliberate in sampling on characteristics that you know are prevalent in your population and trying to get them in your sample, mathematically it has been proven, providing your sample is large enough, that if you are methodical in your randomization, if that's an oxymoron, if you will, but in randomly picking those pieces, those members or units of your sample, you're going to have better luck having it be representative, in this case generalizable as well. So you may want to rewatch this to absorb that information because it will be helpful for this week's homework. As well, with this week's homework, I have provided you a file to get you through some of the characteristics and syntax that you'll need that for the questions that require it. So all in all, that's it for the week. If you have any questions, just ask.